Okay, so let's take a look at 1.5 notes. Um, 1.5 is probability basics. Let's start with some clean sheets here. Okay. All right. Much of the media attention has been focused on the use of. They're going to give us some data. They're giving us a data table to start out with, and this particular data table is about mammograms and detecting breast cancer. Okay. The way we read these is um, we have totals. We have this data. These four boxes are the data. Then we have our totals, our row totals, and then our column totals. Columns go down, column total here, and then this is the total number of people. Okay, so let's take a look at number one, where they're asking what's the percentage of the 10,000 women, that's our total. So our total, remember we're kind of going off the old assumption here of part over whole, although there are um, multiple ways to find, probabilities here. For this problem, we're using part to whole. We may even use part to part on these. Okay. So what percentage of the 10,000 women, so here's our whole 10,000 women, had a positive mammogram. So I'm looking at the positive, let's see, positive mammogram. So we're looking at the positive mammograms here, and um, percent of the one that had a positive mammogram. Okay, the number of women that had a positive would be the total, which is the total number of positive mammogram, which is going to be our 6,432, because that's the total positive mammogram. Now we're looking at, just because it says no cancer here, doesn't mean that they didn't test for positive. Okay, so if you take my calculator, take the 6432 and divide it by the 10,000, I get 0.6432. Now, some probabilities um, are going to be ask you for the decimal. Some will ask you for the fraction. If I want the fraction, just hit math, enter, enter. I get 402 over 625. And some probabilities, especially, well, when we get into it the next page, where we're looking for frequencies, is usually done in percentages. I look at my decimal to change a decimal to a percentage. Just move that decimal point over 2 places, and that gives me the percentage. So the percentage here would be 64.3, and we'll do tenths percent. Okay. Oh, actually, they do ask for the percent, so we'll use percentage. Okay, B, what percent of the 10,000 women, so here we go, the total is our 10,000, had a cancer diagnosis? Now we look at who actually had a cancer diagnosis. Well, here's cancer, and so So the actual ones that had a cancer diagnosis actually included those 76, even though they ended up negative, but they were diagnosed. That total of cancer diagnosis is 378. So you got to be really careful with these tables and these questions, what they're asking for. Okay, so I'm going to take my 378 divided by 10,000. It's going to give me 0.0378. Move that decimal over 2 places. And my percentage that was diagnosed was 3 point, I'm going to round this up to 3.8%. Okay, C, what percent of the women who had cancer had a positive mammogram? Okay, so this time it's going to be a part to part. Okay, so what percentage of women who had cancer, okay, the total that had cancer was 378, had a positive mammogram. Okay, so out of that 378 that had cancer, that included the 76. All of these had cancer. The positive ones were the 302. Oops, 302. Okay, so then I take my 302, I'm going to divide it by 378, and I get a decimal of 0.79. I'm going to round this up again. Move my decimal over 2 places, and I get, of those who were that had cancer, it was 79.9%. Okay. D, what percent of women who had a positive mammogram? So I'm going to look at positive mammogram. Okay. So my positive mammograms total is 6432. Positive mammogram actually had cancer. And the ones that actually had cancer was 302. So if I take my 302 divided by 6472, I get 0.0469. Move the decimal place over 2, and I get 4.7%. Okay, and E, explain why the answers to parts C and D are not the same. What do these 2% actually say about mammograms? Well, I'm looking at it, and I'm looking at the actual positives here. It seems like there seems to be an awful lot of like false negatives here. Right? So that's what my reasoning is. So it looks like the test had a lot of what's called false negatives. Because out of the total that tested positive, you know, almost a lot of them, 80% of them, actually didn't get any cancer at all. Okay, page 2. We're going to talk a little bit about frequency of a number of an. Let's start with the definition. Okay. Relative frequencies, they tell us what percent of the time something happened. Okay, so the frequency is the number of events, number of times, the number of times an event occurs. Relative frequency is the ratio. So you take the formed when the frequency is divided by the total number. So we actually take the frequency and make it a fraction ratio. For example, we had 15 women and 75 were diagnosed with cancer, and those 15 women were tested positive. And when you multiply this out, it comes out to 0.2. As a percentage, it's 20%. That's a relative frequency. Okay? And you can read through this problem. The solution is here. They give some numbers here. So each year, the General Social Survey asks the respondents if they are working full-time, working part-time, going to school, keeping house, and so on. So they got a couple of things here. They got full-time, they got part-time, they got keeping house, school, keeping house, and they got all these different things. So in 72, 1,600 people responded. 1,650 people responded. So that's our total. This is what we're going to use for the total number in 72. 1,615. And then 2014, they're using the total 2,538. So be careful when asking what year, and because you're going to have different totals. So if we're looking at 1972, we have let's see, we're looking at full-time workers. So 72, 750 of them were working full-time. That's where they got this fraction. 750 out of 1972, our total was 1,650. And you divide that out, you get that 0.4644, and you move the decimal over 2 places. That's approximately, that little squiggly line means approximately, that's 46%. And they did that for the other different scenarios here. I'm not going to go through all of these. You can go ahead and look at them, and if you have any questions, please see me. All right, number 2, national survey asks how many people were living in the respondent's household. The following table shows the results. Find the relative frequency of the households. Remember, relative frequency is the ratio formed by the total number, so you got to make a fraction. Find the relative frequency of the households more than 8 people and interpret it. So more than 8. So we're looking at household size. We're looking at more than 8. So we got 9, 10, and 11. Okay, so I need to find the frequencies of those. For this, number of respondents were 300. Well, what's my total? Well, that I'm going to have to figure out. So I'm going to have to add all of these to get my total. Remember, on the table we did on the previous page, don't forget we had to get the totals of our rows by adding them across. So that's just what I'm going to do here. 695 plus 997 plus 385 plus 261, so on and so forth. I'm going to get a total of 2538. So that's my total. So if I go back and look at these, I'm going to have 3 respondents out of a total of 2538. Remember, part to home. So for the 9 household, I got 3 respondents out of 2538. And they want us to find more than 8 people. So I'm going to have to add these 3 frequencies together because that's the data we have, 9, 10, and 11 size households. So that's the 9. I'm going to add to it the 10 households. We only had 1 respondent out of 2538. And then I'm going to have another, for the 11 household, I'm going to have another 1 out of 2538. If you use your calculators, please put parentheses around these. And you're going to end up getting, well, 0.092 or 0012 for the 3 plus the 1 out of 2538 is 0.00039. And of course, this is the same as that. So I got to add another 0.0039. Add all of those together, and I get 0.00198. If I want the percentage, I move that percentage point over 2, and I get about 0.2%. All right, let's talk a little bit about experimental probability. Okay, experimental probability is the likelihood of or chance of something happening. Okay, so experimental probability is the likelihood that something is going to happen. Like if you go to flip a coin, you expect it to be 50% probability. Relative frequencies that tell us what percent of the time something did happen can also be considered as experimental probabilities. Okay, so that's kind of important there. These percents can be used to say what percent of the time we expect something to happen in the future based on actual data. Like I said, flipping a coin, the experimental probability, if you flip that coin enough times, it's going to be 50%. So let's look at some problems. Again, when we have a table of data, we need to get our totals here. Okay. Well, this one's pretty easy. For those people, now we got different age groups that drink at least 1 cup per day. We're going to go ahead and add down the table or down the column. Okay. So 357 plus 342 plus 196. We need a total for all the columns and all the rows, and then we need our total. So we add these 2 together, we get 895. That's if we add down. Okay. If we add across, well, I'm not sure what to add here, but if you add these across, we should get 744. So what I'm going to do here is I know I have a total of 744. I've used up 357, so I'm going to subtract 357. And that's going to give me my total here for this column that did not drink at least 1 cup of coffee of 387. And I'm going to do that again. 519 minus 342 is 177. 266 minus 196 gives me 70. All right. So if I add these across, I get my 744. I just subtracted that out of that total. Now, I'm going to go ahead and add these down to get my column total. And 387 plus 177 plus 70 is my 634. And my total, you could either add these across or these down. 895 plus 634 is my 1529 for the total. That's a total number of people. I'm going to pause here for a minute. Okay, A says find the probability that someone in each age group drinks at least 1 cup of coffee per day. Which age group has the highest probability? So I'm going to look at each one. So the first one, 18 to 44. C, the number of people at least 1 cup of coffee is 357. Out of the total of people in that age group is 744. And that comes out to 0.4798, or move the decimal over, about 48%. Okay, the 45 to 64, see, at least 1 cup is 342. And their total was 519. That comes out to 0.659, which is approximately, move the decimal over, 65.9%. And lastly, 65 plus. Let's see, I have 196. Out of their total is 266. Comes out to 0.7368, which is approximately 73.7%. So the highest one here is 65 and older. So I'm not sure if that showed up on my on the videos, but here it is. Talking, I think it actually, the screencastify screen was on and not the camera. But those are the fractions I was talking about. Okay, number or letter B, find the experimental probability that someone over the age of 65 does not drink at least 1 cup of coffee per day. What's the fastest way to find that? Okay, well, let's do the probability of 65 plus not drink. Okay, that probability, see, 65 plus not drink is 70 out of, let's see, their total number was 266. Put that in the calculator, we get a decimal 0.2632, which is approximately 26.3%. It's not a very good approximate. So. Fine. Oh, what's the fastest way to do this? Well, actually, we had that up here. The 73% for those that did drink it. So if I would have taken the 73.7% minus that from 100%, I would have gotten the 26.3%. That would have been the fastest way. And C, find the overall probability that someone 18 years or older drinks at least 1 cup of coffee. So 18 years or older. So it's going to be all of them drinks at least 1 cup per day. So that's 895. Because that's a total number, at least one. And then that's going to be out of the total of 1529. That gives us a decimal of 0.5853, which is approximately 58.4%. 0.5%. Okay, last page. We've got, here's the coin toss. I'm not going to go through this. Um, this is actually an experiment that if you can do, but eventually with experimental probabilities, you're going to, as long as you have enough sample size, you are going to get what the probability is. Flipping a coin, obviously, is going to get you 50% either heads or 50% tails. Again, the reason why you wouldn't get 50% is if you didn't do enough sample, if your sample size was too small. The more you do, the closer to 50% you'll get. We will take a look at number 5, and I'm going to take a look at the theoretical probabilities. Okay, theoretical probabilities tells us what should happen based on theory and not experimental results. Okay, in other words, let's look at some examples. The following table shows the probability of experiencing certain events in the United States. Okay, so in contracting Ebola, we had 1 in 13.3 million. Dying in a plane crash, 1 in 11 million, so on and so forth. If we were to make or figure out our probabilities from this data, we would take 1 divided by the 13.3 million. That will give us our percentages here. 1 divided by 13.3 is 0.075, or approximately 7.5%. And if I do that for all of these, 1 divided by 11 will give me 9.1%. 1 in 9.6 is going to give me 10.4%. 1 in 5.2, 19.2%. 1 in 3.7, 27%. And 1 in 91 is going to give me 11%. Yeah. A tells us determine approximately how many people experienced each event, assuming the population of the United States is 320 million. So what I'm going to do here to figure out how many people experienced the event, well, I know that I'm going to be multiplying by 320 million, and I'm going to multiply it by each one of these percentages, and actually be easier to do it with the decimal. So the Ebola, which was 0.075, multiply that by the number of people, that will tell me how many million, or how many people out of that had it. In this case, I get 24. 320 times 0.091 is going to give me 29 people. And I do this, each one of these. 320 times 10.4, 33. 320 times 19.5, give me 61. 27% of 320 killed by a shark. 86 people killed by a shark. And killed in a car accident, 35. How many times greater was the probability of dying from a bee sting compared to contracting Ebola? Okay, so the bee sting, I had 86 people. Compared to contracting Ebola, which is 24. So there's if I divide this, it comes out to 2.5 times higher. And that's it for section 1.5. Go ahead and complete the homework, and any questions, please don't hesitate to ask. Thank you.